38 million tons of seaweed in the Atlantic in a single month.
The University of South Florida measured that number in July 2025, a mass so large it was visible from the International Space Station, a brown belt stretching from the West African coast all the way to the Gulf of Mexico, over 8,000 kilometers wide. For 15 years, this has been the Caribbean's most expensive, most humiliating, and most unstoppable problem. Beaches disappeared under masses of algae overnight. Governments deployed military equipment. Resorts spent millions to remove it. And every single morning, more came back. But what engineers figured out to do with it, instead of fighting it, is one of the most unexpected industrial transformations happening anywhere on the planet right now. Let us first understand why the Sargassum spread is impossible to stop. Unlike almost every other algae on Earth, Sargassum never anchors itself to the sea floor. It spends its entire life drifting on the ocean surface and reproduces by simply breaking apart. Every fragment becomes a new plant. There is no root to cut, no source to eliminate. Destroy one patch and you've created 10 more. For centuries, this wasn't a problem. Sargassum lived locked inside the Sargasso Sea, a massive, currentless gyre in the North Atlantic that works like a slow whirlpool with no exit. It stayed there, contained, for as long as anyone had records. But then two things changed, and within a single decade, the Caribbean paid the price. Ocean temperatures in the equatorial Atlantic began rising, and Amazon deforestation accelerated, releasing nitrogen-rich sediment into the open ocean, a perfect fertilizer. The algae consumed it, multiplied beyond any prediction, and escaped the gyre. It made its first appearance on Caribbean shores in 2010. It has returned every year since, each time larger than before. Other algae can be collected and used as fertilizer, a recycling loop that would at least make the cleanup economically viable. Sargassum cannot, because this plant has a biological quirk that makes it uniquely dangerous. It actively absorbs heavy metals from seawater. Its phosphate transporter mistakes arsenic for phosphorus and pulls the poison in like a nutrient. Raw sargassum from the Atlantic belt carries up to 90 milligrams of arsenic per kilogram. The EU's safety limit for animal feed is 2. Spread it on farmland and you poison the soil. And while scientists were still processing that, the scale kept growing. When sargassum rots on a beach, it releases hydrogen sulfide, a gas that smells like rotten eggs mixed with sewage and becomes toxic at high concentrations. In Cancun, the smell reached more than a kilometer inland. Hotels evacuated guests. Schools sent children home. Residents sealed their windows and stayed inside. Rotting sargassum also releases methane, a gas that, over a 20-year period, is 80 times more damaging to the climate than CO2. Cancun spends $37 million every year dumping sargassum into landfills, where it keeps rotting, keeps releasing methane, and keeps making the problem worse. For fishermen, everything changed. Boats sit in harbor, week after week, the sargassum too thick to push through. Fishing grounds that families relied on for generations, gone. No insurance, no compensation. And in 2022, the U.S. Virgin Islands declared a national emergency because sargassum had blocked the intake of a seawater desalination plant. No seaweed removal meant no drinking water. Now let us talk about the costs of this crisis. The Caribbean has always sold one thing: paradise. White beaches, turquoise water, 7 million tourists flying into Cancun alone every single year. In some island nations, 80% of the entire economy runs on that image. And sargassum is destroying it, season by season, beach by beach, because those white beaches now look like this, and cleaning just 1 kilometer costs up to $70,000 per month. For small island nations with no financial reserves, that number is simply impossible. One luxury resort in Cancun employs 40 people, 12 hours a day, all year long, just to keep a single stretch of beach clear. Governments threw everything they had at it, and the numbers kept moving in exactly the wrong direction. By 2018, the bloom had grown so large it became visible from the International Space Station for the first time, a brown continent drifting between Africa and the Americas, stretching over 8,000 kilometers. Reports published in March 2026 describe the mass that is currently moving toward Florida and the Caribbean as the largest marine bioinvasion in recorded history. 2026 is projected to break every record. This is no longer a crisis. It's the new normal, and it's getting worse every year. But a few people refuse to see it as a catastrophe. Some saw the largest free raw material delivery on the planet, arriving at the shore every single year, without anyone having to ship it or pay for it. They started asking, what if this wasn't a problem to be solved, but a resource to be used? And what they built from that question changes everything. This is Omar Vasquez. He built something extraordinary out of sargassum from his garage, bricks. He mixed dried sargassum with clay and sand, 40% algae, 40% clay, 20% sand, pressed the mixture into molds and left them to dry in the Caribbean sun for 28 days. A 500-year-old technique with a carbon footprint 85% lower than traditional clay bricks. And the compression test results were outstanding. His bricks withstood 60 kilograms of pressure per square centimeter before breaking. Mexico's minimum construction standard requires 35. Bricks made in a garage outperformed concrete. And there's one more thing. Sargassum bricks block heat 4 times more effectively than standard concrete, cutting air conditioning costs by up to 30% with zero technology, zero energy. And every wall built from them locks away carbon that would otherwise rot on a beach and release methane into the atmosphere. Not carbon neutral, carbon negative. A material governments were paying to bury was quietly outperforming the materials they were paying to manufacture. And that is not the only idea engineers figured out. This is Legina Henry, mechanical engineer at the University of the West Indies in Barbados. She fed sargassum into an anaerobic digester together with rum distillery wastewater and the manure of Barbadian blackbelly sheep. The combination sounds like a local recipe. The result was compressed natural gas capable of running a car. For an island like Barbados, that has always depended entirely on fuel imports, this is more than a clever experiment. It's a pathway to energy independence, powered by a raw material that arrives at their shores in tens of millions of tons every year, at zero cost for cultivation, land use, water, and fertilizer. The ocean delivers it for free. Meanwhile, in Mexico, a team of researchers solved what had seemed like the hardest problem of all, the arsenic. Raw sargassum carries up to 90 milligrams per kilogram, 45 times the EU's safety limit for animal feed. Their solution? Hot water, citric acid, and lactobacillus bacteria, the same microorganisms used to ferment yogurt. Arsenic levels dropped from 76 milligrams per kilogram down to 1.64, a 98% reduction. With that discovery, sargassum could finally be used as fertilizer, as animal feed, as raw material for industries around the world. The same material that governments were paying to collect, transport, and dump now generates between $80 and $200 per ton in processed output.